In this video, we'll look at implementation of stack using array. Let us start a project and call it as stack array, and the language is C language. Create a project, and this is the main function. I'll clear off all these comments. Now, first of all, let us define a structure for a stack. First of all, let us define a structure for stack. As we have already seen that for representing a stack, we need the size of the stack and a top pointer to point on topmost element in the stack and a array for storing elements. Let us call array name as S. I'll take capital S. This array I'll be creating it dynamically when I am creating a stack. Then when we create a stack, we have to initialize its size and the top pointer and also create an array. So for that, I will have one function called create. So this create function should take structure stack and call by reference st. Now here I will take the input from the keyboard that what is the size of the stack, and I will create and initialize the stack. And a size, then scanf percentile d. I should read the size, so already I have a pointer to a stack, so in that I will directly read it in size. Now once we know the size, we should create an array, but before creating array I will also initialize a top pointer to -1. Then this pointer s I should initialize with an array. So here I should create an array dynamically in heap. So it's an array of type integers, malloc, and the size of the array should be same as the size mentioned for the stack, and this should be size of integer. That's all. A stack is created. Size is set and its top pointer is initialized to -1 and an array is created. As I am using malloc function, here in the top I should include header file that is stdlib.h. Now I will write on a function for displaying a stack. So first let us write a function for display which will take a structure stack st. This should be called by value because it's not going to modify a stack, just it's going to display. And for displaying we need a for loop, so for that I'll take I, and we should display it from the top. So I assign top I greater than or equal to 0 and I minus minus. I should print all the values, so percentile d, then some space, then the values are in a array s inside an object st. So this will print the entire stack. Then after printing it, I should give a new line so I get some formatted output. That's it. This is a display function. Now we'll write on few push and pop functions in the stack. Now we'll write on the actual operations on the stack, that is push and pop function. First I will write on push function, push void push. It should take a structure stack and it should take it by address and the value that I want to insert. Here, as we have already seen the procedure, so first of all I should check whether there is some space in the stack or not. If st's top is equal to st's size -1, then stack is full. We cannot insert anything. So printf stack overflow I will say, and new line. That's all. This is the message I can give. Else we can insert an element. So first of all we should increment the top pointer, and then in an array s I should store the value at top location, whatever the value is given, x. So that's all. This is a simple push operation. Then I will write on pop function. Pop function should return a deleted value, so return type is integer. It should take a stack by reference, that is by address, so again star st, and whatever the value is deleted we will take it in some variable, so initialize it to -1. Then before deletion we should confirm whether there are any elements in the stack or not, that is we check whether it is empty. So condition for empty is if top is equals to -1, then the stack is empty. If so, then we will give a message that stack underflow, a new line. Else we can delete an element. So for deleting an element, take a value from an array from location that is top. And also we should decrement top pointer. So simultaneously in the same statement I will also write minus minus, so this will decrement the top pointer. And after deleting, after else part, I should say return x. So this pop function will delete the value if it is available, otherwise it will return -1 if the stack is empty. The other operations I will write them afterwards. So first of all let us use this push, pop and display functions and let us see how the stack is working. So first of all I will create a object of stack st. The stack name is st. Then I will call create function by passing address of stack st. Then I will push few values. Push in the stack st, the value I want to push first is 10. Then push value 20. I'll push few more values. Now let us display the contents of stack. So for this also I should send stack st. Let us run this. I have pushed 10, 20 and 30, so I should get the display from the topmost value will be 30, so I should get the values 30, 20 and 10. Here is asking for the size, so I will give the size as 5 and the values are 30, 20 and 10. Yes, it's working. The topmost value is 30. Recently inserted value is 30. Let us push more than 5 values and see what happens. st, I'll push 40 also, then push 50 also. Okay, then one more, push st 60 also. So I'm pushing 6 values in the stack. Let us run it now. So first of all, I have written the code such that it's asking for the size. So I'll give the size as 5. So only 5 values are inserted. You can see 10, 20, 30, 40 and 50. Topmost value is 50. And when I was trying to insert 60, it has given a message that stack overflow. So I got a message that is stack overflow because stack is full. We cannot insert more than 5 values. So beyond this, if I try to insert any more values, I get a message that stack is full, that is stack overflows. So I cannot insert this. Now let us try pop function. Pop function is going to return us the result, so I will directly print its result %d. I will take new line, then call pop function and send address of the stack. So whatever the value is deleted, it will return and that value will be printed. So the recently inserted value is 50, so I should get 50. Then after that, when I display, I should have the values 40, 30, 20 and 10. Enter the size. So I'm taking the size as 5. Yes, you can see that 50 is deleted and the remaining values in the stack are 40, 30, 20 and 10. Now let us look at stack underflow message. So I will remove these 3 values. I will delete more than one time. So printf delete once more pop st. See, there are only 2 values in the stack. If I delete one more time, then I should get a message that is stack underflow. I should not be able to delete and it should return -1 because if the stack is empty, it is returning -1. Here you can see x value is initialized as -1, so it is returning x. Now stack is having only 2 values that I am pushing and I am printing, but I am deleting 3 values, that is 3 times pop. So let us run. I should get a message that stack underflow. Size, I am mentioning size as 5 only. See the values popped out or deleted values are 20 and 10. Then after that, when I am trying to delete stack underflow message, I got stack underflow. Then the value that is returned is -1. Now, as both the values are deleted, there is nothing in the stack, so there is nothing to display. So display function is not printing anything because stack is empty. That's all we have tried push and pop functions. Now let us write remaining functions of a stack, that is peak, is empty, is full and stack top. And in that way, we'll be completing all the functions of a stack. So first I will write down peak function that will look into a stack at a particular index. If the element is available, then it will return the element. So this, it will take it as index. I will call it as index. So it's taking a stack and the index. So whatever the value we are getting, we will take it in a variable. So initially I'll put it as -1 and I should check whether the index given is valid or not. So if st stop, that is stop, minus index +1, if it is less than 0, then it is invalid index. So let us print a message that invalid index. Otherwise, we can return the value. So first of all, let us take the value in the stack. So st.sArray, I should take the value from st stop minus index +1. Then I should return the value, return x. I will try this function, I will use it. But before that, let me write down other functions also. I should have a function called isEmpty. So it should take a stack, then it should check whether top is equals to -1. So if st's top is equals to -1, then return true. That is, yes, it is empty. Otherwise, return false, 0. This is isEmpty function. Then one more function I have to write down, that is isFull. So I will write function isFull, which will take structure stack st. Then here the condition is if top is equals to size -1. So I will simply say return top st's top is equals to st's size -1. If this condition is true, it will return 1, otherwise it will return 0. So if it is full, it will return 1, otherwise it will return 0. It's perfect. Then I should also have a function for stack top. So I'll give the name as stack top struct stack st. This is again called by value. So it should return topmost element from the stack. So but before returning, it should check whether there are some elements in the stack or not. If the stack is not empty, it can do that. If not is empty, so it can call the function that is empty. If it is not empty, then it will return st's top value. Otherwise, return -1 if there is no top element. So if it is not empty, then it can return it, otherwise return -1. So that's all. We have all the functions ready for stack. See, one more thing, while explaining on whiteboard, I have not taken care of a strict syntax. Just for the explanation, I was writing pseudocode. Now here you can see the implementation exactly. So let us use this peek function. So for that, I will push few more values, then I will perform peek operation st, comma 30. I will push the values what all I have pushed earlier. So same st 40. Yes. Now instead of pop, I will call peek function. So here I will say peek. So I'm just modifying the code. I'm not writing a call once again. Now the index what I want is 1. That is the first element. So I should get 40. So let us run this. It's asking for the size. I have to give the size. Size is 5. Yes, topmost element is 40. That is index was 1. Now I will modify this one here. I have given index as 1, so let us give index as 2, so I should get the element 30. See, the element is not deleted from the stack. Stack is still having 40, 30, 20 and 10. Stack size, I'll give size as 5. Now the element from the top is 2. Second element is 30. So yes, this is the second element from the top, and the element are as it is, it's not deleted. That's all. This is full and is empty and stack top, you can try them. I have written all the functions. So if at all anywhere we require a stack in a C language program, then we will utilize this stack. If at all we require a different data type, then we will change the data type of this array, that is S, this pointer, and also wherever we are inserting an element, there we will modify it. Like this push is taking an element, so we will change the data type. So we have to change the data type of the element array as well as the other variables which are dealing with that array. So that's all. This is the implementation of stack using array. So the program is little lengthy and I have not elaborated main function. I have just tested the functions here. If you want, you can make a menu driven program for a stack with providing all the options like push, pop, peek and is empty, is full, all the options that you can try. Like one of the beginning programs, I have shown you a menu driven program. That same thing you can implement here.